Welcome. This video is over part-to-whole relationship concerning bar graph, circle graph, and dot plots. So here are two box plots. They're about girls and boys and their height as 7th grade students in inches. So before I even do anything, I'm going to first move and label these. This is minimum. So the minimum girl is 56 inches, while the maximum girl is 68 inches. The median, the halfway point for the girls, is 63 inches, and median, the lower half of quartile 1 is 61 inches. Median of the upper half of quartile 3 is 65 inches. So the minimum boy is 58 inches. So that means the shortest boy is still 2 inches taller than the shortest girl. The maximum boy is 70 inches. The median is 65 inches. The median of the lower half is 62 inches, and the median of the upper half is 67 inches. The next part is to label the percentage. A box plot is 100%. It's divided into 4 quarters or 4 sections. So 25% goes in each section. So 25% goes here, 25%, 25%, 25%. Imagine that there are like 8 students. If we divided those 8 students into 4 sections, there were 2 students in each 25%. So let's do the same thing for boys. 25% goes here, 25% goes from here, 25%, and 25% goes here. So in our question, it says, let's start with girls. It says, what percent of the girls are 61 inches or higher? So let me highlight the girls, 61 inches. That's 3 quartiles or 75%. Who has a higher interquartile range? For girls, again, interquartile range is the range from quartile 1 to quartile 3. It goes from 61 to 65. How far is it from 61 to 65? That's 4 inches. Well, for boys, who has a higher interquartile range? It goes from 62 to 67, or 5 inches. So boys has a higher interquartile range. So we are given a dot plot. There are dots there, and it's plotted. So this dot plot shows the number of free throws made by the members of a basketball team during their last game. What is the ratio of players who made at most 2 free throws to the total number of players? Write it in simplest form. In case you forgot what ratios are, ratio can be written in fraction form. It can be using the word 2 and colon. It's comparing 2 different numbers. So our first number we want to compare is at most 2 free throws. How many players made at most 2? That's an inequality we learned in the past. That means 2 is the most number of free throws they could make. Can they make 2? Yes. But can they make lower? Yes. So it's 0, 1s, and 2. So that's 5 students who made at most 2 free throws to the total number of players. 1, 2, 3, 4, 5, 6, 7, 8, 9 to 10. Can 5, 10 be simplified? Yes. I can divide the numerator and denominator by 5 and get 1/2. That means half of the basketball players or half of the team made at most 2 free throws. This is a bar graph that you learned in elementary school. So this bar graph, it shows the number of pets that the student in Mrs. Meyer class own. Find the ratio of students who own 1 pet to 3 pets. So let's count. How many students have 1 pet? 10. How many students have 3 pet? 2. Can I, simplest form. Divide both sides by 2, numerator and denominator by 2, and it's 5:1. So the ratio is 5:1. That means there are 5 for every 5 students who have 1 pet, there's only 1 student who has 3 pets. Do not say the answer is 5. In a ratio, you have to compare 2 numbers, so 5:1. So what you're going to be doing now is you're going to be given this dot plot and answer 5 questions. You will be working with your table and doing this, but because in the video, we'll do it together. Mrs. Suarez surveyed her students to determine how many brothers and sisters they each have. The dot plot below represents the results of the class survey. Each dot represents 1 student. Please count the total number of students surveyed. I've already counted earlier. There are 24 dots. Find the median. There are many ways you can do median. You can list out the numbers 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, until you find the median. I'm not going to do that. Instead, I'm going to cross cross it off like this way, from the least to the most, least to 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 least to most, least to most, least to most, least to most. So the somewhere right here. So 2 is the median. And what is the mode? 2 is the mode because 2, 1, 2, 3, 4, 5, 6, 7 was responded. I mean, many students responded with 2. I have 2 brothers and sisters. So there's like 3 in the family, or 3 kids, that is. Just like what I have. So what fractional part of the student in Mrs. Suarez's class has more siblings than the class median number of siblings? So what is the median? 2. So how many students have more than 2? 1, 2, 3, 4, 5, 6 out of 24 students. Can I simplify that? You bet you can. Divide the numerator and denominator by 6, 1/4. So 25% or 1/4 of the class has more siblings than the median. What fractional part of the student in Mrs. Suarez's class has fewer siblings than the mode? The mode is 2. So how many students have less than 2? 1, 2, 3, 4, 5, 6, 7, 8, 10 out of 24. Divide both sides by 2, and you get 5, 12. What is the ratio of the number of students having at least 2 siblings to the number of students having less than 2 siblings? So at least 2 siblings, at least. That means 2 is the least they can have, the lowest number they can have. But can they have higher? Yes, they can. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now we compare it to the numbers, compare the number of students having less than 2. Can it be 2? No, it has to be less than 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this can be simplified by dividing by 2 and get 7/5. If a new student with 1 sister joined Ms. Suarez's class, what would be the mean number of siblings for the class? We're not going to do this one, so I'm going to scratch this one out because I don't really have access to a calculator here, or I do, but I'm not going to, we're just going to skip this one for now. What is the ratio of the number of students having either 1 or 2 siblings to all of the siblings in the class? So what is the ratio of the number of students having either 1 or 2 siblings? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To all the students. What's the ratio of the number of students having either 1 or 2 siblings to all the students? And that would be 5/12. Okay, that's the same answer as that one. What fractional part of the students in Mrs. Suarez's class have fewer siblings than the mode? Fewer siblings than the mode. 2, 4, 6, 8, 10. Yep, 10, 24. And what is the ratio of the number of students having either 1 or 2 siblings? Let me look at something right here. 10, 24 was, yep, same answer. All right, so now that we understand this, so now we have a circle graph here. So is circle graph a 7th grade material? So a graph that displays data as part of a whole is called a circle graph. In a circle graph, the percents add up. If I add up all of these percent, it will add up to 100 since the entire circle represents the whole. We can solve problems using data represented in a circle graph. When solving problems involving percents, we can use strategies such as mental math or setting up a proportion. Remember, we can only use mental math if we are given the total. So here is a circle graph about the percent of favorite single topping pizza. A total of 250 students were surveyed. How many students prefer pepperoni as their favorite topping? So let's see. If we know 100%, so we're going to use mental math for 100% is 250 students. What would 10% be? 10% divided into 10 parts would be 25. And our goal is to find pepperoni, which is 30%. So if 10% is 25, 20% would be 50, 30% would be 75 students. So 75 students. Let me erase that. What if I do not want to do mental math? I'd rather do proportion. Perfectly okay, by the way. So what percent like pepperoni? 30% out of 100. Because remember, what is a percent? 30 out of 100. But how many total students are there? There are 250. Do you remember something in the beginning we learned in previous called part over whole equal percent over 100? It's the same thing. So how do you write 30% as a fraction? 30 out of 100. And our goal is a 250. So how do you build 100 to 250? We multiply by 2.5 is the scale factor. So 30 times 2.5, 5 times 0, 0, 15. Cross out. 2 times 0, 0, 6. Adds up to 750, but don't forget the decimal point, so we get 75. Did you prefer mental math or did you prefer proportion? Either one will get you the answer. So now how many students do not prefer pepperoni? If there are 250 students and we take out 75 of them, we are left with 175 students who do not prefer pepperoni. Here's another question. A total of 250 students were surveyed. How many more students prefer cheese than other? So how many more students like cheese than other? Here's cheese. Here's other. That means 20% more people like cheese than other. There's a 20% difference. So let's use mental math. 100% of 250 is 250. 10% is 25. So 20% would be 50. Instead of a proportion. So 20%, there's a 20% difference between how many more students like cheese than other. And how do you write 20% as a fraction? 20 out of 100. And then there's 250 total students. So how do you build it from here? Oh, wait. Can we do an up and down relationship? Let's do that. That's easier. How do you turn 100 to 20? Divide by 5. Divide by 5. You get 50. Ah. If not, I could just multiply 2.5 as a scale factor, if that's what you prefer. So what fraction of the total number of students prefer cheese as their favorite topping? Well, 35% like cheese, so 35 out of 100. Could I simplify that if you want to? Yeah, divide by 5, divide by 5, that'd be 7/20. That'd be 7 out of every 20 students will say, I like cheese. So 105 students prefer cheese as their favorite topping. How many total students were surveyed? So in this one, we can't really do mental math for this one because we are not given the total here. So we know cheese. They're asking about cheese. So 35% of the people like cheese, or 35/100. So these are people who like cheese. And then 105 prefer cheese. That's not the total, so it goes up here in the proportion. That's part of the students. Can 35 be built? Can 35 go into 105? It cannot. We're going to have to simplify. That's why I asked you to simplify earlier. 35 and 100 simplify to 7/20. Now, can 7 go into 105? Wait, stop. 35 actually does go into 105. We do not need to simplify. I apologize there. Because, let's see, 35 times, is it 3? Let's see, 15 carry to 1. Yeah, it is times 3. Times 3. You know what? I'm going to move this out and pretend I never saw this one. So it is times 3. So that means there are 300 total students in the survey. Now that we know the total number of students surveyed, 300, how many students chose mushroom as their favorite topping. Well, 20%. Oh, I want to do mental math here. So 100% of 300 is 300. 10% is 30 because I broke it into 10 parts. So 20% would be 60. So the answer is 60. What if you would do a proportion? So 20% out of 100. And how do you build it to 300 times 3? And you get 60 there. So this is what we did with part to whole relationship, talking about percents, ratio, many things that we learned in the past.